So the next question that we have is question example number 12. So in example number 12 we have show that the coefficient of the middle term in the expansion of the so we have the coefficient of the middle term in the expansion of in the expansion of 1 plus x raised to the power 2n is basically this coefficient. If I call it, for example, if I call it a, if I call this, for example, I don't know, not a, but for example, m, for example, is equal to the sum of the coefficients of two middle terms in the expansion of 1 plus x raised to the power 2n minus 1. The sum of the coefficients of the two middle terms in the expansion of 1 plus x raised to the power 2n minus 1. Call this, for example, n. And so basically we want to show that basically m is equal to n, right? So to show that m is equal to n, we need to calculate the coefficient of the middle term in the expansion of 1 plus x raised to the power 2n. So let's do that first, and then we will take care of the coefficients of the middle terms in the expansion of this. So in order to do this, so basically about the expansion basically 1 plus x raised to the power 2n, since the exponent is even. So we said that if the exponent is even, we will get, if n is even, we will get only basically one middle term. We will have only one middle term. Which would be basically n plus n divided by 2 plus 1/3. So n divided by 2 plus 1/3 would be basically Okay, so now basically in order to calculate n plus 2 plus 1th term in this expansion, what I need to do is that over here, as you can see, your index is equal to 2n. So I have to put n over here, which is the index. I have to put it as, I have to use 2n here, which means that basically n plus 2 n divided by 2 plus 1th term. So therefore the n plus 2 plus 1th term in the expansion of 1 plus x raised to the power 2n would therefore be basically 2n divided by 2, whatever the value of the index is here, you have to substitute it with basically the index here, 2n divided by 2 plus 1 plus 1th term, which is equal to basically 2n divided by 2 is n plus 1th term, n plus 1th term, which is the same thing as t of n plus 1, right? So at t of n plus 1, of course you know that the value of your r is equal to 1 less than the term number, which becomes n, and your index is basically meaning that relevant to 1 plus x at t of, since we are talking about 1 plus x raised to the power 2n, at t of n plus 1, which is the middle term, your r is 1 less than the term number, which becomes basically n plus 1 minus 1, which is equal to n, which is what I have written over here. Your index over here would be the same index is equal to 2n, and your basically your a would correspond to 1 and your b would correspond to x, and the formula that you use is basically n combination r, a raised to the power n minus r, b raised to the power r, which is equal to t of basically t of r plus 1. Okay, so now this term is actually called t of r plus 1 because, well, it's as a general term. Now t of basically t of n plus 1, which is basically n plus 1th term, t of n plus 1, you see that this notation is actually a little bit confusing, at least to me. So you have to understand the meaning of the notation and the meaning of the different basically things that is used in the notation. And the reason is that, of course, if you don't understand the meaning, you will not be able to use it. So that's that. But for example, you need to understand what is meant by, for example, when you write t of n plus 1, what is meant by that exactly? And so for example, when I write t of n plus 1, that means basically n plus 1th term in the expansion of, for example, a plus b raised to the power n. You get one term over here plus another term over here plus another, and so on and so forth. So this would be the first term. This would be, for example, the second term. This would be, and so on and so forth. And somewhere over here, some term over here would be n plus 1th there, right? That is, of course, assuming that even if you had raised to the power n, or you would have n plus 1 term over here, n plus 1 terms over here, which would be the last term, for example. So that's basically what is meant by t of n plus 1. And then there is one more thing here that needs to be noted. When you write t of n plus 1, which is n plus 1th term in the expansion of this binomial, if you pay attention to the expansion of a plus b raised to the power n, here you can see that you have n combination r, or n combination 0, a raised to the power n minus 0, b raised to the power 0, plus n combination 1, a raised to the power n minus 1, b raised to the power 1, plus n combination 2, a raised to the power n minus 2, b raised to the power 2, plus all the way up to n combination n, a raised to the power n minus n, b raised to the power n, right? And the general term of this expansion is generally noted as n combination r, a raised to the power n minus r, b raised to the power r, and you can see that the same thing is happening over here, meaning that you have n combination 0, then a raised to the power n minus 0, then b raised to the power 0, b raised to the power r. Again, n combination 1, a raised to the power n minus 1, b raised to the power 1, and so on and so forth. So this is the general form of the general term of this expansion. And therefore this number over here, which is basically all of these numbers down here, this is in this expansion is called r, right? Now, as you can see, now in each of these expansions, in each of these terms, that, for example, of course, you can see that this is the first term. The first term is denoted by t of 1. This is the second term, which is basically t of 2, and so on and so forth. And so at t of 1, you can see that r is equal to 0. At t of 2, your r is equal to 1, and so on and so forth, right? And what that means is that at any term, the number that you get as r is always 1 less than the term number. For example, the term number over here is 1, your r is equal to 0. Your term number is 2, your r is equal to 1. Your term number is 3, for example, here, your r is equal to 2, and so on and so forth. So when I write over here t of n plus 1, that means n plus 1th term. N plus 1th term in the exact same way that this becomes the first term, then that this becomes the second term, that this becomes the third term, and so on and so forth. So with that in mind, then I can say that basically, and moreover, these concepts basically in mathematics have a lot of applications, meaning that these are the tools that you have to use in your toolbox. All of them have to be there, all of the chapters that we do here. And then wherever you go, you will need a combination of these tools put together in order to get something done. So if you miss any of these tools, somewhere you will get stuck, right? It's always like this. So now t of n plus 1, I can write it as over here. I have written at t of n plus 1, my r is basically 1 less than the term number, which becomes basically n. My index is basically 2n, and basically the first quantity is basically 1. This is the expansion that we are talking about. So my index is 2n here, and my first quantity is 1, my second quantity is x, and I'm using this general form of the formula, which means that then t of n plus 1 is equal to basically n combination r. N over here, n refers to the index, and the index over here is 2n, so I write 2n combination, and r over here is equal to n, so I write 2n combination n, and then a, which is the first quantity, over here is 1, so I write 1 raised to the power n minus r. So n minus r is basically this number minus this number. 2n minus n is equal to n. And b, which is in this case x raised to the power r, which is this number here, and that would be x raised to the power n, so that is 2n combination n, x raised to the power n, and that is t of n plus 1 in the expansion of 1 plus x raised to the power 2n, which is also the middle term, right? So that is what we were actually looking for. Now, the question that we asked here was basically we wanted to prove that the coefficient here, as you can see, is 2n combination n, right? So the question that we asked here was that basically the coefficient of the middle term in the expansion of 1 plus x raised to the power 2n, which in this case happens to be basically 2n combination n, we wanted to show that this coefficient is equal to the sum of the coefficients of the two middle terms in the expansion of 1 plus x raised to the power 2n minus 1. Which means that I need to find I need the two middle terms in the expansion of this binomial, and as a result, basically then add them together. That should be equal to the coefficient of this one over here. Okay, so now what I need to do is that I need to find the middle terms in the expansion of 1 plus x raised to the power 2n minus 1. So now about the middle terms, in the expansion of 1 plus x raised to the power 2n minus 1, we have, so 1 plus x raised to the power 2n minus 1, so 2n minus 1 is an odd number, of course, assuming that n is a positive integer. So assuming that n is a positive integer, then 2n minus 1 would be an odd integer. And therefore we said before that when the index is odd, the number of the middle terms is basically 2. Namely, namely n plus 1 divided by 2 and n plus 1 divided by 2 plus 1. N plus 1 divided by 2 and n plus 1 divided by 2 by 1. So now, since we are talking about 1 plus x raised to the power 2n minus 1, the index over here is 2n minus 1, so so basically then, therefore n plus 1 divided by 2 would correspond to basically the index over here is 2n minus 1. So instead of n, I have to write 2n minus 1 and add 1 to that and divide it by 2. That would give me 2n divided by 2, which is equal to n. That means the nth term in the expansion of basically 1 plus x raised to the power 2n minus 1. And basically n plus 1 divided by 2 plus 1 and n plus 1 divided by 2 plus 1 would correspond to the next term, which would be basically n plus 1th term in the expansion of 1 plus x raised to the power 2n minus 1. Therefore, we need to calculate the nth term and n plus 1th term in the expansion of 1 plus x raised to the power 2n minus 1, which are the middle terms, right? Which are the middle terms in that expansion. Now, so what that means is that the expansion that you have is 1 plus x raised to the power 2n minus 1, and you want to calculate the nth term and the n plus 1th terms. The formula meaning that you want to calculate t of n and t of n plus 1, the formula that you have there is basically n combination r, a raised to the power n minus r, b raised to the power r. So now at at t of n, your r is equal to basically 1 less than the term number, so n minus 1. Your index is equal to 2n minus 1. 2n minus 1. Your a would correspond to 1, your b would correspond to x, and therefore this formula becomes basically 2n minus 1 combination r, and r here is basically n minus 1, a would be 1 raised to the power 2n minus 1 minus n minus 1, which is equal to 2n minus 1 minus n plus 1, and these two you can cancel out. 2n minus n is equal to n, so that would be 1 raised to the power n. And then you have x raised to the power n minus 1, and that would be basically your, and that would be basically t of n. This is equal to t of n. Therefore, t of n is equal to 2n minus 1 combination n minus 1 times x raised to the power n minus 1. That is one of the terms that we wanted to calculate. Now, at t of n plus 1, your r is equal to basically 1 less than this, so that would be equal to n. Your index is equal to the same thing, 2n minus 1, because we are talking still about the same expansion. Your a would correspond the same thing, b correspond to the same thing, again because we are talking about the same expansion, and therefore the same formula, meaning that t of basically n plus 1 would be equal to basically n combination r, so that would be 2n minus 1 combination r is equal to n here, and 1 raised to the power 2n minus 1 minus n, which is equal to 2n minus n is equal to n minus 1, and x raised to the power n, which is the same thing as, so t of n plus 1 is equal to 2n minus 1 combination n x raised to the power n. So this is basically that. Now, here we know that basically, we said that the sum of these two is the sum of the coefficient here and the coefficient here is supposed to be equal to the coefficient here, right? So the coefficient of basically of the middle term of this expansion was 2n combination n. So now 2n combination n is supposed to be equal to 2n minus 1 combination n minus 1, 2n minus 1 combination n minus 1, and add to that basically 2n minus 1 combination n, right? Now we had so we have 2n minus 1 combination n minus 1 plus 2n minus 1 combination n is supposed to be equal to 2n combination n. Now we had in the basically in combinations we had something. This is the binomial theorem. In combinations we had something, and that was basically n combination. There was a theorem that we proved in the end of the chapter related to combinations and permutations, and that was theorem number 6. Theorem number 6, which said that basically n combination r plus n combination r minus 1 is equal to n plus 1 combination r. N plus 1 combination r. This was theorem number 6. So here you have basically, if you take 2n minus 1 as n here, so 2n minus 1 combination n minus 1 plus 2n minus 1 combination n is supposed to be equal to, of course, n, which is basically 2n minus 1 plus 1 would be equal to 2n, so that you would get 2n combination n, which is basically the larger number. The larger number is r, so that would be 2n combination r. 2n combination n, actually 2n combination n. So based on this, you can verify that this is true, which is true based on theorem number 6. So based on this theorem, you can see that this is true, and these two are the coefficients of these two middle terms in the expansion of 2n in the expansion of basically 1 plus x raised to the power I don't know where I have started talking about 2n minus 1. Over here. You see, over here, we have started talking about 2n minus 1. And in the expansion of 1 plus x raised to the power 2n minus 1, these are the two terms, these are the two middle terms, and this is basically one of the coefficients. This is the other coefficient. I have added them together and written them as 2n minus 1 combination n minus 1 plus 2n minus 1 combination n, and then I have written that as the sum, as basically the middle term in the expansion, basically in the expansion 1 plus x raised to the power 2, and the coefficient was the middle term of the coefficient of the middle term was 2n combination n. So I have written that over here, right? And then based on theorem number 6 that we have proved in the chapter related to combinations and permutations, this is actually true, which proves what we wanted to prove, right? Okay, so that is basically example number 13. That is example number 13. I'm sorry, that was example number 12. That was example number 12. The next one is example number 13. Okay, so the next question is example number 13. Find the coefficient of a raised to the power 4 in the product using the binomial theorem. So you want to, example number 13. Find the coefficient of a raised to the power 4 in the product 1 plus 2a all raised to the power 4 times 2 minus a raised to the power 5 using the binomial theorem. So you want to find the coefficient of a raised to the power 4. Okay. Now, the way that you can solve this problem is that, of course, a raised to the power 4 you see one of these terms is going to give you, if you have 1 plus 2a raised to the power 4, 1 plus 2a raised to the power 4, at some point, or in one of the terms, you're going to get so basically this would start with basically the first term, that is basically a raised to the power 0, which would be just a constant. This would be a constant. Then you have some coefficient, some a raised to the power 1, a raised to the power 2, a raised to the power 3, and so on and so forth. And you would end up with a raised to the power 4 in the end. And that is basically all the terms that you have here, because this is a raised, this raised to the power 4. You cannot go higher than a raised to the power 4. Over here, 2 minus a raised to the power 4. This is going to give you negative, positive, but that's not important, because then you would get negative and positive terms when you multiply them together, which is again not important. Important is that basically you're going to get some constant. You're going to get some constant, some a raised to the power 1 all the way up to, and this is raised to the power 5. This is raised to the power a raised to the power 5. And so you're going to get a raised to the power 1, and there is some coefficient here, a raised to the power 2, all the way up to a raised to the power 5, right? Now when you multiply these together, you are going to get, for example, you are going to get a raised to the power 1 times, for example, over here you have a raised to the power 3. You're going to get some a raised to the power 4 here. Again, when you multiply a raised to the power 2 by a raised to the power 2, you're going to get some a raised to the power 4 here. When you multiply a raised to the power 0 times a raised to the power 4, you're going to get some a raised to the power 4 here. And therefore, you will get a bunch of those terms, and then you have to add them together. The coefficients will be added together, and that becomes the coefficient of a raised to the power 4 in the product, right? Now, there is no automatic way that you can basically carry out this operation. The way that they have solved this problem is that they have actually expanded both of the binomials. They have expanded both of the binomials, and then they have basically then the terms that will lead to a raised to the power 4. They have written the terms, they have multiplied them together, and then they have added them together, and then that way you can find the coefficient. Otherwise, there is no other way to do that. So that's basically how you can solve this problem, basically. So now what I'm going to do is that I'm going to first expand this first binomial as basically 1 plus 2a raised to the power 4. 1 plus 2a raised to the power 4. And so this would give you basically 4, for example, combination 0, 1 raised to some power, which is essentially 1, and 2a raised to the power, for example, 4 minus 0 is equal to 4, right? No, I'm sorry, that would be basically raised to the power 0, right? that would be raised to the power 0. So that would be 4 combination 0, 1 raised to the power 4, for example, and 2a raised to the power 0. So you can write this as just simply 4 combination 0 because this is 1 and this is also 1. The next term is basically 4 combination 1, 1 raised to some power, and 2a raised to the power, whole raised to the power, basically 4 minus 1, which is equal to 3. Plus 4 combination 2, 1 raised to some power, 2 raised to the power 2. And 4 combination 3, 1 raised to some power, 2a raised to the power, basically 3. And then 4 combination 4, and you have 1 raised to some power, 2a raised to the power 4. And that's basically where you have to stop, right? Now you can keep this as it is, meaning that, or you can multiply them, meaning that 4 combination 0 is equal to 1, and 4 combination 1 is equal to 4. 4 basically, and that is supposed to be equal to 1 actually. I apologize for this mistake. So that's 4 times 2a, which is equal to 8a. Which is equal to 8a. And then over here you have 4 combination 2 and 4 combination 3. 4 combination 2 is the same thing as 4 factorial divided by 2 factorial 2 factorial. So you can write that as 2 factorial times 3 times 4 divided by 2 factorial times 2, and then you can cancel this 2 out, cancel this out, and yet then you will get a 6 over here. So 4 combination 2 is equal to 6 times 2 raised to the power 2 is equal to 4, 4 times a squared, 4 times a squared, 4 times a squared, 4 times a squared. Then you have 4 combination 3, 4 combination 3 is the same thing as basically 4 factorial. And 1 factorial 3 factorial, which is equal to 3 factorial times 4 divided by 3 factorial, and that's equal to 4. So 4 combination 3 is equal to 4 times 2 cube is equal to 8a cube, right? 8a cube. And 4 combination 4 is equal to n combination n is equal to 1, right? So that's 2 raised to the power 4 is equal to 16a raised to the power 4. And then if you do this calculation, what you will get is basically 1 plus 8a plus 24 times a squared plus 32 times a raised to the power 3 plus 16 times a raised to the power 4. That is 1 plus 2a raised to the power 4. That is basically that. Now 2 minus a raised to the power 5, 2 minus a raised to the power 5, whole raised to the power 5, is the same thing as basically n, which is 5 combination 0, 2 raised to the power basically 5, and basically a raised to the power 0, right? Minus 5 combination 1, 5 combination 1, then you have 2 raised to the power 4, and a raised to the power 1 times a, plus 5 combination 2, 5 combination 2, then you have 2 raised to the power 3 and a raised to the power 2, minus 5 combination 3, basically 2 raised to the power 5 minus 3 is equal to 2, and a raised to the power 3, a raised to the power 3. Then you have plus 5 combination 4, 2 raised to the power 5 minus 4 is equal to 1, and a raised to the power 4. And then you have 5 combination 5, 2 raised to the power 5 minus 5, which is equal to 0, which becomes 1, and a raised to the power 5, right? Now 5 combination 0 is equal to 1, and 2 raised to the power 5 is equal to 32. 5 combination 1 is equal to 5, 2 raised to the power, that's a 5, 2 raised to the power 4 is equal to 16, and you have a negative sign over here as well, times a. 5 times 16 is equal to 50, 30, 80, and that's negative 80 times a. Negative 80 times a. Then 5 combination 2 is equal to 5 combination 2 is equal to basically 5 combination 2 is equal to 5 factorial, 5 minus 2 is equal to 3 factorial, 2 factorial, which is the same thing as basically 3 factorial times 4 times 5, 3 factorial times 2, and then you can cancel this out, you'll get a 10. So then 5 combination 2 is equal to 10. You have a 10 over there, and that's a positive sign. 2 cubed is equal to 8, and a squared, that's equal to 80 a squared. Then you have 5 combination 3. You have 5 combination 3. 5 combination 3 is the same thing as basically 5 factorial, 2 factorial, 3 factorial, which is equal to 5 or 3 factorial times 4 times 5 divided by 2 times 3 factorial, and then you can cancel this out, you'll get a 10. So you have negative 10 times 2 squared is equal to 4, and then you have a cube, so that's equal to negative 40 times a cube. Negative 40 times a cube. And then you have 5 combination 4. So 5 combination 4 is equal to 5 factorial, 1 factorial, 4 factorial, which is equal to 4 factorial times 5 divided by 4 factorial. Cancel these two out, you'll get a 5 over here. And therefore you have basically 5 times 2 times a raised to the power 4 over here, which is equal to 10 times a raised to the power 4. 10 times a raised to the power 4. 5 combination 5, I don't know where this actually comes from. This is not supposed to be here. Well, this is supposed to be here actually. So you have basically 32 minus 80a plus 80a squared. You have to write this basically this way. This plus 80 times a squared, but this is not there. Minus 40 times a cube plus 10 times a raised to the power 4, which is already what we have written over here. And so you have plus 10 times a raised to the power 4, which is basically 5 combination 4. And then 5 combination 5 is equal to 1. So this is not there. And then 5 combination 5 is equal to 1 plus a raised to the power 5. That means that 2 minus a, whole raised to the power 5 is equal to 32 minus 80 times a plus 80 times a plus 80 times a squared plus 80 times a squared minus 40 times a cube plus 10 times a raised to the power 4 plus a raised to the power 5. And if you multiply, if you get these two and multiply them together, so you have 1 plus 2a raised to the power 4 is equal to 1 plus 8a plus 24 times a squared plus 32 times a cube plus 16 times a raised to the power 4. And if you multiply all of these, basically these terms together, basically the terms that can give you a raised to the power 4 would be, so you can say that the terms containing a raised to the power 4 would be basically, you can take this 32 and multiply it by this. So you have 32 times 16, 8 raised to the power 4. And other than that, it's not possible. And then this term, if you take it and multiply it by this term, meaning that negative 80a times 32 times a raised to the power 3, that gives you a raised to the power 4 as well. If you take this term, you have to multiply it by this term, meaning that 80 times a squared, you have to multiply it by 24 times a raised to the power 2. If you take this term and multiply it by this term, meaning that plus negative 40 times a cube times basically 8a times 8a, and if you take this term and multiply it by this one, so plus basically 10 times a raised to the power 4 and multiply it by 1, that gives you a raised to the power 4, and this never gives a raised to the power 4 and it's multiplied by anything. So that's equal to 32 times 16. 32 times 16 is the same thing as 32 times 16. 6 times 2 is equal to 12, 1, 18, 19, 0. 1 times 32 is 32. So you have 2, 11, 1, and 512. So 512 a raised to the power 4. And then you get a negative sign there. Then you have 80 times 32 times a raised to the power 4. So 32 times 8, you have a 0 there. So that's 16, 1, 24, 25, 25, 60, 25, 60 a raised to the power 4. And then you have 88 times 32, again the same thing. So you have a positive 832. 80, 32, 80, no, that's different. So 8 times 24 with a 0, 32, 3, 16, 19, 19, 20, plus 19, 20, a raised to the power 4. And then you have 40 times 8, which is equal to negative 320, 320 a raised to the power 4. And then over here you have plus 10 times a raised to the power 4, which means that you have all of these coefficients added together. So you have, these two are negative, so I add them together to 2560 and 320. So you have 0, 8, 8, and 2, that's negative. And then the positive ones are 512, 19, 20, and 10, and 10, and so you have a 2, you have a 4 over here, you have a 13, 9 plus 1 is equal to 14, 14, and 1, so 2, 4, 2, 2, 4, 2, 4, 4, 2, positive, And so the term would be, if you subtract this negative, this negative number is, the absolute value of that is greater than this number. So I write 2880 and subtract from that 2442, and then I have a negative sign there. So I have basically 7 and 10. 10 minus 2 is equal to 8. 7 minus 4 is equal to 3. 8 minus 4 is equal to 40. So that's negative 438. 8 raised to the power 4. Negative 438. 8 raised to the power 4. So that is basically, and the coefficient becomes, of course, negative 438. Negative 438 is the coefficient. So that is basically that. That was question number 13. In the next video we will do question number 14, 15, 16, 17. So I'll see you in the next video. Thank you.